Hey guys, in this video, I'm going to be covering multiplying integers and modeling that using counters and a number line. So before we start, I want to remind you that multiplication does have this property. It's called commutative property. That means it does not matter what order we are multiplying numbers in. It's going to have the same product. So we could say 5 times 3, or we can do 3 times 5. It's going to give us the same answer. 15. Okay, so it doesn't matter really what the order is for multiplication. We can kind of switch the numbers around and it will not change the answer. Alrighty, so here is my first example. Ready? So 3 times 4. Now I'm going to do this showing you what it looks like with counters as well as a number line. So let's start with counters. For counters, the first thing that you are going to do is look at the key. Okay, so I have my key, and just like if you're looking at a map and you want to know what those symbols mean on the map, and you look at the key, when map reading is the same thing here. Okay, so you're going to look at your key and know that in my key for this problem, yellow counters are going to be positive and red counters are going to be negative. Okay, now this could be anything. It could be a red apple and a green apple. It could be a blue dot or an orange dot, a yellow dot and a red dot, anything. So you need to make sure that you're taking a look at the key so you know what is positive and what is negative. Okay, so my key says my positive numbers are going to be represented by a yellow counter. So I looked at my key. The next thing you're going to do, step 2 in our notes, is our very first number, right? So our problem is 3 times 4. Our very first number, 3, we're going to go ahead and model that using the key. So 3 is positive, so I'm going to use a positive yellow counter. 1, 2, 3, and then I'm going to group it. There we go. And then step 3 is determine how many of these groups I need. So that is what the second number tells us. So 3 is how many counters go in the inside, and 4 tells us how many of these groups, just like that one, I'm going to make. So there's the first group. So I'm going to make 4 of these groups really quickly. 4 groups of 3 counters. Now your answer is going to be how many counters I see there. I see 12 counters and they're positive. Again, I know it's positive because of this key right here. That key tells us that it's a positive 12. So our answer is going to be 12. Alrighty, so if I were given a number line, same thing. We're looking at 3 times 4. For a number line, just like in our notes, step 1 is we're going to start at 0. For multiplying, we are always going to start at 0. And just like how our first number 3 told us how many counters are in the inside of a group, that 3 is going to tell us how big our arrow is going to be. So my arrow is going to be positive 3 in length, so I'm going to start at 0, and I'm going to draw my arrow to 3. That 4, just like how it tells us that we need 4 groups, that 4 is going to tell us how many arrows we're going to use. So that's my first arrow, 1, 2, 3, 4. Now notice that my arrows are all the same length. They are all the length of this 3 right here. Okay, so between 0 and 3, that's 3. Between 3 and 6, that's 3. Between 6 and 9, that's 3. They're all the same length. Okay, they're the length of 3, and then I had 4 arrows, just like how I have 4 groups. And I got to my answer at the end over here, which is 12. Okay, so very, very similar. Let's try another one. What happens if it's negative? Okay, so let's go ahead and do our counters first. I have negative 3 times 4. Negative 3 times 4. Now we did take a little note in our, make a little note in our notes that if you see a negative number, I want it to be first. Okay, so this one does have a negative number, it's negative 3, and it's already first, so we're good to go. I took a look at my key. I knew that the yellow counters are positive, the red counters are negative. And I'm going to go ahead and model this negative 3 right here using red counter. So same thing, 1, 2, 3, and then I'm going to group it. And then my second number right here tells me how many of those groups I'm going to have. I'm going to have 4 of those total. So 1, my second one. 3 and 4. Okay, so I have one group of negative 3, 2, 3, and 4 groups of negative 3. And my answer is going to be how many total counters I have there. I have 12 total counters, and they are red. I looked at my key. Red is negative, so my answer is going to be negative 12. Okay, so if I'm showing this with a number line, we're going to start at 0. The first number, it tells us how long our arrow is, -3. So this time I'm going to the left, -3. Okay, now same size arrows. How many arrows do I need? I need 4. That's what that second number tells us, just like how it tells us how many groups we need, how many arrows. 1, 2, 3, and 4. So I'm going to end on my answer there, which is -12. Alrighty. Let's do one more here. 3 times -4. What happens if my negative comes second? Now remember that commutative property, the first thing that I said in this video. For multiplication, it doesn't matter which number comes first, we're still going to get the same answer. We're still going to get the same product, right? So 3 times 4, the little note that we made in our notes is if you see a negative, if you have one negative number, go ahead and make it first. So I'm going to rewrite this. I'm going to swap these two because we know it's going to give us the same answer, -4 times 3. So this is what I'm going to be modeling. Okay, because there's no way for me to really show you a negative group, but I can show you a negative counter, right? I can show you -4. So I'm going to go ahead and model this first number. I looked at my key. I know the reds are negative. I'm going to model 1, 2, 3, 4, and then I'm going to group it. And how many do I need? I need 3 of those groups. I'm going to make 2 more. One, 2, 3. Okay, and my answer is going to be how many total counters there are? There are 12, and they are negative. So -12. Now, if I wanted to do a number line, I'm going to do the same thing. Let's make this blue so you can see it. I'm going to start at 0. I'm going to model, or I'm going to show you the length of the first arrow using that first number, -4. So my arrow is going to be the length of a -4. And then how many arrows do I have? Same as the number of groups I have, 3. That's my second number. So 1, 2, 3, and I'm going to end on my answer there, which is -12. Alrighty, so an important thing is, can you see the problem in your model? So I know a lot of you guys, you can tell me what 3 times 4 is, you can tell me, what 5 times 3 is, you can tell me the answers. But one of your expectations for this year is, can you match the problem to the model? And if I gave you a model, could you tell me what the problem was, right? So can you see the problem in the model? If you cannot see the problem in your model, then that means you're modeling a different problem, okay? So let's look at this example here. On the left side, we have -6, but also on the right side, we have -6, right? So on both sides, our answer is the total number of counters we have. On both sides, we know that our answer is -6, but they look different. So these are models for 2 different problems, right? So on the left, we have -3 times 2. We have -3 in each group, and we have 2 groups. Now, I can very clearly see the -3, right? This is a -3. I can very clearly see that there's 1, 2, and 3 counters in there. So we know that this problem is modeled right there. The other side gives me the same answer, but it's a different model, so it's a different problem. This side is -2 times 3, because I see my negatives. I see my 2 negatives. This is -2, and I see very clearly 1, 2. I see the -2, and I see 3 groups of them. Alrighty. So if I had this problem right here and I tried to model it this way, right, we see that there's a discrepancy, right? I see that my problem has -2, but I don't see a -2 in this picture right here. I see a -3. So make sure that we're going back to this one. Make sure that you can see the problem in its model. If you can't see the problem in its model, then you're probably modeling something else. Alrighty, I hope that helps. That's multiplying integers using counters and a number line.